Before we get to the tutorial, I want to mention that this is the first tutorial in a series that I've never done before, so let me know if you have any suggestions. I'll probably change the formatting around a few times in the next few tutorials here and there, just to see what works out best. This was about a 15-minute video that I cut down to 30 minutes, so I didn't want to redo the whole thing. I had to redo it 2 times before the final result, so that was, quite a bit of time to spend on a tutorial, and I didn't want to redo it. And some of the stuff I cut out the 3D vectors portion, and I think I mentioned that in the video as I edited it. So let me know if you have any suggestions. This is the first tutorial of the series. And keep that in mind. Let me know if you want more diagrams, less diagrams, things like that. Alright, stay tuned for the tutorial, and hope you enjoy, and I hope you will enjoy the series as a whole. Thanks. Hey, Nathan here. Welcome to the first video of the Game Math series. So in this video, we are going to discuss vectors. And I mentioned in the last video that I'm using a Surface Pro 3 so I can draw. And occasionally I'll detach my keyboard so I can move my Surface Pro 3 around so I can get a nice drawing angle. So if you hear something being detached and reattached, that's probably it. So, vectors. I released a monogame, well, I didn't release it, I created it, a monogame tutorial for moving a sprite. And we used vectors for position and velocity. So vectors it gives us a physical representation of our object. You will probably use this in 90% of your game projects for position and velocity. You might use acceleration in some projects. You might use force vectors in some projects. You can change when you draw a sprite, you can change the origin, and that uses a vector for that. So there's a lot of things we can do with vectors. So sometimes you want to manipulate vectors, and you might need to create it depending on, you have an angle you want to go, you want the object to travel, and you have a speed you want it to be. How do you get the vector? Now I explained that in code, but if you want to understand the math side of things, you can watch this video. So I created a few pages. We might create a few more as we go along, just to keep things simple. I created a few pages here. So the first thing we want to do is discuss the coordinate system and the diagram. So a mathematical coordinate system is something like this, and that is positive x, and that is positive y. So if this here, if that's 3, 2, that means that is positive 3 and positive 2. Positive 3 in the x and positive 2 in the y. Now the DirectX coordinate system, also known as the pixel coordinates or the screen coordinates, is this. That is positive x and that is positive y. So this point here will be 3, 2. Just like we have this point here, that will be 3, -2 in the other. So this is the math Cartesian coordinate system, and this is the screen coordinate system, or just the screen coordinates and pixel coordinates. And that's what DirectX and other game technologies use. So things will be a little bit different. I will discuss, in general, the the Cartesian coordinate system when I do diagrams. So that is the coordinate system and the diagram. So let's look at the diagram for vectors. So I'm going to use the Cartesian coordinate system. That's x and that's y. So a vector it holds a magnitude and a direction. That's the definition of a vector, as magnitude and a direction. You have an angle that the vector operates, and you have the length of the vector, the magnitude of the vector. So a vector would look like this. So that here is the angle. Theta is usually used for the angle in mathematics, so you might see me do something like that for theta. So that's the angle, and then that's the length or the magnitude. Length or magnitude of the vector. So we have that. Let me draw it a little bit bigger here. So we have the length here. So I'm going to draw a dotted line from the arrow all the way down to the axis here. So a vector not only has the angle and the length, but we can get the y component and the x component. And that's what we'll use in most of the games. You know, we might have the angle we want to work with, and then the speed we want to achieve. That's speed here. We need to get the x and y components, so that we'll cover that in vector operations here. Okay, so that is the coordinate system in the diagram. So the diagram will look like this. We have a y and x component. We have the angle and the length or the speed or the magnitude here. So let's talk about the notation. So when you look at a vector in a mathematics or a physics book, they show you the components. That way you can do simple mathematics, add or subtract components and stuff like that. The notation is very important, and that will give us an idea of where it is in terms of x and y. There are several ways to look at a vector, and I will list the three most common ways, depending on the book and the person providing the videos or the online guides or whatever you might use. A vector might appear different. So we usually represent a vector with V and an arrow. Usually V is the standard. You can name it A, B, C, or whatever, but it's usually identified as a vector with the arrow above it. So it can be A with an arrow. So that's an A vector. So ordered set notation. All right, so let's discuss that. Ordered set notation. So we have a vector V. We identify that with an arrow, and that is usually a parentheses x comma y closing parentheses, or V arrow is equal to angle bracket x comma y closing angle bracket. So that's known as the ordered set notation. There's also the matrix notation. And that is identified by using the vector is equal to normal bracket x, and then just a space in between, and then y closing normal bracket, or you can do that vertically. So that is a matrix notation. The last thing you'll probably see in most physics books, and that's the engineering and physics notation. And that is identified by using the unit vectors, and the unit vectors are usually labeled I, and then a caret above it, J, and a caret above it. Now, I'm discussing two dimensionals at this point. Three dimensionals, you just add a XYZ here, XYZ here, XYZ here, and Z here. So you just add a Z component there. For the unit vectors, the z component is k with a caret for 3D. So that's the three-dimensional component. That is the k is the unit vector for a 3D vector for z space. So what is a unit vector? A unit vector just has a length of 1, and that is used to determine the direction. So x will go in the x direction, y will go into the y direction as a length of 1. So I caret will be 1, 0. 1 in the x, 0 in the y, has a length of 1. And then j will be 0, 1. So that is the unit vector. So this is a lot more complex, so you'll see it in more complex books. But if there's some, physicist or engineer that discusses, they have game tutorials and stuff and they want to talk about vectors, they might use this kind of notation. So v is going to equal to the x component times the I unit vector plus the y component times the j unit vector. So that is the engineering or physics notation. So let's go ahead and go to vector operations. So sometimes if you're working on a game, you might encounter a problem and you need to work on something on paper to figure it out. So it's a good idea to know some of the math operations you might encounter, like if you're adding two vectors and it's not working out right. So let's have a vector A, and it has its components ax, ay. Whatever a and x and a of y, whatever they are, the math will be the same. Now we have a vector here for b. And that's going to be bx, by. And then we have some scalar value, c. And that's just some random number. That's what a scalar is. Just any given number. It can be a decimal point or it can be just a simple integer. So if we want to add something, add two vectors together, the math becomes ax plus bx, ay plus by. So adding the vectors a and b provide the addition of the x components and the addition of the y components. Alright, what about a minus b? Pretty much the same thing here. A minus b is equal to ax minus bx, ay minus by. So that is the subtraction from the x components and the subtraction of the y components. Now, if you want to multiply a vector by some scalar value, and this will come into play when we do updating our position because we use the elapsed game time as seconds. So some scalar times some vector is going to be some scalar times that vector's x component, some scalar times that vector's y component. So the scalar times the vector is equal to the scalar times each component. And then the same thing for 3 dimensions, for z. Just add a z here. You see we have X and Y. If you're in 3D, just add a Z here. And the same thing for this. Add a Z here, and a Z here, Z here, Z here, and you'll be good to go. Another thing you might come into an issue with is how to visually combine a vector. If you run into an issue in your game and you need to figure out a way to combine vectors, but you don't want to deal with the mathematics side of things, you can visually add vectors together. So let's bring up the Cartesian coordinate system. And that's X, and that's Y. So we have some vector here, U. That's another common letter that they use for vectors. And then we have some vector here, V. So we have a U and V. Now graphically combining these vectors will result in this. U plus V. So you graphically combine them by going to from the starting region and then going to the end of the resulting one. Alright, getting a vector between points. Sometimes you want to write an object that you want to create that in a way that it will follow another object. There are complicated ways of doing that, and then there are easier ways. The easiest way is to grab a vector that goes from point A to point B, or to other vectors, and normalize it. And that normalizing it will make sure that the length of vector is 1. We'll get into that later. Now, if you're doing this kind of thing for monogame, this will not be built in. You'll have to do this manually, so this might be important for you. So a vector between points. This is important. That's if you want something to follow another object. You will definitely want to do this math, and you have to do it manually. So we have a vector A, and that is AX, AY. And we have another vector B, and that is BX, BY. Now, V is going to be a vector between A and B. So we have some vector A here that exists and some vector B here that exists. We want the vector V to be between A and B. So V is going to be BX, sorry about that, BX minus AX, comma, BY minus AY. Now, what's different with this than just A minus B? If we go back to A minus B, we have AX minus BX. But on V here, we have BX minus AX. So the operation switched. It's not AX minus BX here, it's BX minus AX. And that is different than AX minus BX. Now, I created a PDF tutorial on this back in 2009, and this goes into a lot of the graphical representation as well. I will provide this for you, and I'll add this to the description. So I'm not going to go through all the displaying all the graphic stuff. You can check that out. Okay. The magnitude, what I mentioned earlier. Magnitude, or the length of the vector, is the value of the longest side of the vector. In 2D, that's the diagonal. You can use this to calculate the distance an object has traveled, collision detection. You can use that for correction. If you have an object that travels so fast that from one game loop to another game loop, it completely passed through the object, you can do collision detection correction based on the amount of distance it traveled. Or you can use it to determine an object's speed or acceleration. Let's go ahead and create a new page for that. A vector's magnitude can be represented by having the v for vector and having a single line on both sides, or having v and having double lines on both sides. You might see them one way or the other. Now, what does this mean? We have some vector a here, and that is equal to ax comma ay. So what is the magnitude? That is equal to the square root of ax squared plus ay squared. On some libraries, this is built in. That is built in on some libraries. On some other things, you might have to code it yourself, and that is the mathematical way to create the magnitude of the vector. Alright, so let's do something simple, and let's discuss a basic example. So a here is equal to 4, 7, and then b here that's going to be 3, 2. Alright, so the magnitude of a is going to be 4 squared plus 7 squared, the square root of that addition, and that's equal to 65 square root, and that is equal to approximately 8.062. A, just for fun, let's plus a plus b, and that equals to 4 plus 3, comma, 7 plus 2, and that is equal to 7, 9. So the vector a plus b is 7, 9. Some scalar value 3 times some vector a, that is equal to 3 times 4, 3 times 7. That is equal to 12, 21. So as you see, some of the math stuff here going on, and that's just some basic examples. Now, when I mentioned normalizing, when I mentioned a way to make an object follow another object, I mentioned that you would have to normalize, and we would get into that later. So to normalize a vector, you must turn it into a unit vector, which is a vector with a length of 1. So normalizing it will just make sure we are moving the correct direction. The length will be 1. Sometimes you might need to do this if you're doing a lot of vector math, you want to make sure that your object still travels at the same speed. So you manipulate all of your vectors, and then you normalize it, and then you multiply it by the speed. So this is very important to use in game development, where if you have some force manipulating on your position or velocity, and you have your acceleration affecting your velocity, and your velocity affecting your position, but you still want to travel at the same exact speed. You have a maximum speed. You don't want a car going 5,000 miles per hour. So you have a maximum speed that can achieve. So all your vector math, you need to normalize that resulting vector and make sure the length becomes the correct speed of your object. We do this a lot in our later game projects. So if v is any given vector, let's let u be its unit vector. So no, whatever the values of v's components are, u will be its unit vector. So u is equal to 1 divided by the magnitude of v times v. And that equals to v divided by its magnitude or its length. So u is equal to 1. The length of u is equal to 1. So all you have to do is get this. This is some scalar value. That's some scalar value. We just divide the components of v by its magnitude, and that will turn it to a unit vector. Now I have a proof in my PDF if you're interested to see. I still don't understand how that is guaranteed to be 1. You can check out the proof. It's pretty interesting. Alright, now we're getting into the good stuff. So let's label this good stuff. Well, I'm still not used to the on-screen keyboard. That's why I got the type cover, the Surface Pro 3, the $130 keyboard for this. This is another very important thing. If you have components of a vector, you want to find out the angle. At some point in your game, depending on the way things work, you might have your vector and you need to find out the angle. For some reason, your rotation value might get out of sync with your velocity. In that case, you need to find out the angle of the vector. Now, this is not built in, so you have to know the mathematics behind it. So we need to find an angle of the vector. So let me draw the coordinate system here. That's y, that's x. We have some vector v here. We have some angle here. We have the y component here. So that's vy. And the x component here. So we need to get this value. What is the angle of this vector? We don't know. There are a lot of operations and a lot of useful things that we can do. For any given vector, v, its angle is v theta. Now you can draw the arrow and then theta if you want. I usually don't draw the arrow, so I'll just erase that. And that can be determined 3 ways. For those of you that are familiar with trigonometry, you'll know where this is going. So the angle of the vector, you can use tangent, the inverse tangent, and that's Vy divided by Vx. These need to be known if you do it this way. So if you use tangent, both the x and the y component need to be known. The next way is inverse cosine. And that's Vx divided by the length of vector. So in this way, only the x component needs to be known. And the last way is inverse sine, Vy divided by the length of the vector. So depending on what you know, usually this you'll use a tan 2 in your programming language, or API, depending on what you're using. Okay, so let's discuss the basic trigonometry functions. Tangent of an angle is equal to Vy divided by Vx. We'll get into why we need these later. Cosine of any angle is equal to Vx divided by the length of the vector. Sine of any angle is equal to Vy divided by the length of the vector. So the reason we need these is we have a list of mathematical operations that we can perform to find vector components. So we can find vector components by doing these various things. The y component can be found by multiplying the x times tangent of some angle. The x component can be found by dividing the y component by tangent of some angle. The x component can also be found by multiplying the magnitude of the vector cosine of the angle. This is important. The y component can also be found by multiplying the length of the vector times sine of some angle. This is important. These two are the most important things that you will use in your game. These are the most important is because you usually have the angle you want your object to travel, and you have your speed. You have those two values, and it's easy to get the x and y component based off those values. That's what we did in the second tutorial of the Mono Game series, where we discussed moving an object. by using the keyboard input. We have the speed the object needs to travel, and we get the angle by the keyboard input. If it's up, the angle is 270 degrees. If it's down, the angle is 90 degrees. If it's right, the angle is 0 or 360 degrees. If it's left, it's 180 degrees. And then we obviously have a static speed that the object travels. So these two are very important. Memorize these two or save them as a reference sheet, whatever you need to do, because you will use this probably more than any other mathematical operation for vectors in any game. Okay. I think that's pretty much it for the basics that I want to cover. I just wanted to make sure to mention that these most two important values here. There's a lot more stuff in the PDF, like the dot product and the cross product. And then it goes on to discuss the X and A. You know, this was made back in 2009, so it has some X and A stuff. So just ignore that. You can use some of it for mono game. So I'll put a link on this in the description and on my site. It was made in 2009, so keep that in mind. It's pretty dated. But I had a lot of this stuff, so I hope you enjoyed this, and I hope you will enjoy the series. Next tutorial is not decided yet. If I have any requests or whenever I get to a tutorial that needs a math discussion. And I will provide this. I'll just provide the PDF of the tutorial made in 2009 for you to read. You really don't need to worry about this stuff.